Newton's third law is for every force 1, 2, there exists an equal but opposite force 2, 1, where both force 1, 2 and force 2, 1 are both vectors. Again, Newton's third law. For every force 1, 2, there exists an equal but opposite force 2, 1, where both forces are vectors. Now, in a different class, in a different school, you might have learned that for every action there exists an equal but opposite reaction. This was a good example of Newton's third law for a different class, but it's not good enough for our class. We need something that's a little bit more specific. What two issues I have with for every action there is an equal but opposite reaction. We could have this. I could walk up to Emily X and go like this. I could shove her and she could say, "Oh, Mr. Palmer, I don't like that." That would be an action and a reaction that has nothing to do with Newton's third law. Sorry, I had to do that to you. Another thing is, action-reaction implies that first you have an action and then a reaction, like one happens first and then the other happens. It's not true. For every force 1, 2, there exists an equal but opposite force 2, 1, and they happen at the same time. Some examples to make sure that you understand what this is. Please observe, this is going to be an example of Newton's third law. The 1 and 2 are objects. In this particular case, the two objects are the book and the desk. For every force 1, 2, there exists an equal but opposite force 2, 1. In order to understand this, we need to first remember what the definition of a force is. Please remind me, Andrea, what is a force?
The ability to cause a change in state of motion. The
ability to cause a change in state of motion of an object. So, we need to have evidence that the desk applies a force on the book. What evidence do we have that the desk applies a force on the book? Queen. Actually, the sound has to do with the air and pressure and various sound waves, which actually doesn't have to do with the forces acting on the book necessarily. So it doesn't actually have to do with the sound. Your Chishan.
The book stops.
The book stops, right? The book is in motion, and then that motion stops, so we have a change in state of motion. What evidence do we have that the desk applies a force to the book? Ian. I'm asking you specifically because you were sitting in the desk. Did you feel anything? Did you feel the desk vibrate at all? Okay, good. Okay, it was very alarming. Okay, good to know. So the book applied an equal but opposite force to the desk, and what that does is it sets the desk into a vibration motion. It doesn't actually move it from one place to the next, but it does set the book into motion. I'm sorry, set the desk into motion. I'll use you as well. This will be fun. All right, Ian, here's what I need. I need you to turn, face me just a little bit. There we go, good. What I'm going to do is I'm going to take and I'm going to throw the medicine ball at you. You're going to catch it. Are you ready? Good, thank you. Putting it on the pen. All right, very nice. Throw it back. Okay, so what you're looking for here is we have two objects. We have the medicine ball and Ian. There is a force from the medicine ball on Ian, and Ian applies an equal but opposite force on the medicine ball. Watch one more time. Great. What evidence do we have that Ian applies a force on the medicine ball? Victoria? No, this is only while he's catching it. It's okay. Emily Cat?
The ball stops.
The ball stops. So again, the ball is in motion and then it stops. What evidence do we have that that the medicine ball applied a force on Ian? Nick? Actually, it's not just his hands. If you watch, his whole body ends up moving a little bit, right? Because I picked something that's very massive. Okay, so you have equal but opposite forces here. We have a force from the medicine ball on Ian, and Ian applies an equal but opposite force on the medicine ball. These are all examples of equal but opposite pairs for Newton's third law. And we can have all sorts of examples. We'll have another one over here. In this particular case, we have Mr. Palmer and the wall. Mr. Palmer applies a force to the wall, and the wall applies an equal but opposite force to Mr. Palmer. What evidence, Aaron, do we have that the wall exerts a force on Mr. Palmer? I stopped. I was flying through the vacuum that you could read, and then I stopped. All right. Eric, you were right there. What evidence do we have that Mr. Palmer applied a force on the wall? Okay. I moved the wall. Okay. I didn't actually cause the wall to move from one location to another, right? Because the wall has enough mass, enough tendency to resist a change in state of motion, that I didn't actually change its location. But I did probably set maybe the drywall in vibration or something like that.